Yes, guys. In last lecture, we cover Foster circuit, right? Okay. So today we will see some problem on that, and we also cover uh, core circuit, right? So see here. Okay. See in this circuit. Wait a second. Now, for this Foster one circuit, this is a standard. Uh, Circuit for this Foster one. Foster one we always represent in the form of this impedance function. Okay, so this impedance function is nothing but the series combination of various elements. So we have to identify that element. Okay, now how to proceed it? These are the some standard circuit, and the respective impedance and admittance function is given here. Now simple how to find it this. You have to first of all use the Laplace transform for this circuit, right? This is the time domain circuit. Once you do the Laplace transform of this circuit, and when you find the this z of s, you will get this. Now see, inductor is represent in terms of ls, right? This is a the value of L is A here. So when I use Laplace transform for this circuit, this AS is represent your AS. This A is represent your AS. Similarly for the capacitor, how to represent the capacitor? So this AS is nothing but your Laplace transform, right? See, both are same. When you do the Laplace transform for this capacitor, so how to represent capacitor is 1 by Cs, right? So here capacitor value is 1 by A. So when I represent in S domain, or you can say when I take the Laplace transform for this capacitor, so what you will get here 1 by Cs. So C value is 1 by A. That is 1 by Cs is nothing but your A. C value is 1 by A, right? So this is nothing but your A by S. Now see, compare this. This is the Laplace domain of this circuit. Okay, so this generally this term is given to you in synthesis part. You have to identify the circuit, right? So there are different z of s is given for this Foster one. Foster one is always represent for impedance, right? And Foster two is represent admittance of your circuit. So the equation is given in this format, right? You have to draw the respective circuit. So you have to learn that uh, you have to learn this, or you can also find at the time, but they are time consuming, so better to learn this format circuit, right? Keep in your mind, so it is better to analyze at the time of examination, so it save your time. So now, in terms of this admittance parameter, so the same way, how to represent capacitor in admittance format is Cs, right? When I take the Laplace transform this admittance, so generally capacitor is represent your Cs, or you can say is it is nothing but the inverse of impedance. So you can also say that z of s is represent 1 by cs. So how to y of s is represent 1 by z, that means 1 by 1 by cs. So cs is going to numerator side, so that is nothing but your this cs. So here a value is represent your c. The same way inductor. Okay, so these by this you can analyze your circuit, or you can draw the respective circuit by observing this value admittance form. Now when you compare, this is the equivalent circuit is this format. There are number of element, So this box is nothing but your combination of this uh, combination of any one of this circuit, right? The same way, this is a number of element are nothing but the combination of this circuit. Now there are one example which I take here. Okay, so this is nothing but here z as s square plus z by s square plus 4 into s square plus 16. So how to proceed in this question? So first of all, this the process is given here. So you need to find out the z of s. Okay, so after finding the z of s, uh, you have to solve that, or you can make the arrangement in denominator. There are a factorized form, right? Then you have to split that function, and after splitting that function, you have to compare that function with the standard function, which is nothing but your this table. Okay, from this table. So once you compare this, you can also draw the synthesis circuit, right? So these are the steps. Now proceed one by one. So first of all, see here. So this is your circuit, right? So this is already in the factorized form, right? Observe the denominator. So how to write this? Z of s is nothing but your, take the partial fraction of that. So how to do the partial fraction? Okay, so this is a quadratic equation and it has a two factors, so I can uh, write this in this format, right? S square plus 4. Now observe, this is a s square term and numerator is s term. The difference is should be 1. The second one is bs plus s square plus 16. So this is a partial fraction. I hope you are very well known the partial fraction. Okay, so when you here you need to find out this variable a and b. So how to find out that variable? And this is nothing but your s into s square plus 10 divided by s square plus 4 into s square plus 16, right? Simple. You have to multiply this denominator with the whole equation, so you will get as from numerator side, right? And when you multiply this denominator, what will the term on numerator side is s square plus 16. So s square plus 16. Same way, you have to multiply this second factor, so you will get s square plus 4 here bs. The third one is only numerator term are present for this right hand, yes, right hand side, right? Now solve that circuit and compare the this equations. So this is nothing but your as cube plus a 16 as, right? 16 as plus bs cube plus 4 bs is equal to your s cube plus 10s. Now compare the equations. This is nothing but your a plus b is equal to 1, and second one is this term 16a plus 4b is equal to 10. Now you can also solve this circuit. This is a simple one, so you can solve directly, but there are some complex equation also are present, came in your different type of questions. So at that time you directly use your calculator. Okay, I hope you are known how to use that in your calci. Okay, so when I solve this circuit, so what I get, you will get a is equal to nothing but your 1 by 2 and b is nothing but your 1 by 2. Now put that value in this equations or in this equation. Okay, now when I use that in your equation, this is nothing but your as by s square plus 4, right? As by s square plus 4. So what is the value of a is 1 by 2. 1 by 2 s by s square plus 4. Similarly, b value is 1 by 2 s by s square plus 16, right? This 16, right? Yes. Now you can find this value. You already find this value. Now compare this equation. This is nothing but your s, z of s is nothing but your z1 of s plus z2 of s. Okay, z1 of s plus z2 of s. Now we are talking about z, right? So this is nothing but your Foster one form, right? So Foster one form, we only talk about your impedance function. So observe this. What are the function is represent here? This is nothing but here in the form of, in the form of as by s square plus b, right? See, observe that this is nothing but here as by a square, sorry, s square plus b format, s square plus b format. Now this is function is nothing but here parallel combination of, parallel combination of lnc value, lnc value. See here, observe, as by s square plus b is nothing but your parallel combination of these. So how, what is a c value is nothing but your 1 by a, and what is a b value is a by b. Okay, a by b. So by observing this, you can easily calculate this a and b value. So what is a value for this circuit is, for this, what is a c value, that is c1. C1 is nothing but here 1 by 2, right? Which is a is nothing but here 1 by 2, and c is nothing but here 1 by a, so it will be 2, right? 1 upon 1 by 2. So you will get 2 farad here. And what is the L1 value here? L1 value is nothing but here a by b. So a is nothing but here 1 by 2 and b is 4. So 1 by 2 into 4 is 1 by 8, right? Henry. So this is your C1, C2, and what is L, sorry, C1 and L1, and C2 and L2. What are the values of this? Is nothing but your C2 is 1 by A, and this is same, so it is 2 farad. And for this L2, what is the value of L2 is nothing but your 1 by 2 into 4, 16, 1 by 32. So 1 by 32 Henry. And what are the equivalent circuit for this? Equivalent circuit for this. Now C1, L1, and C2, L2 are known, right? These are, you you are finding this. Now you have to represent that in equivalent circuit parameter. So simple. This is a Z Foster one circuit. So you have to represent in this format. Now this is a parallel combination of L and C, right? So simple. This is C and this is your L in series with C and L. Okay. So you can also cross verify your circuit. This circuit you can also cross verify when you take the Laplace transform of this circuit and compare with your standard function which is given in your question. Okay, so you can verify it and it will be same. So and sorry, this is, this is for inductor value and this is for capacitor value. 2 farad is capacitor here and 1 by 32 Henry is inductor. Okay, so this is your equivalent circuit for this function. Now for this second function, you need to obtain the second Foster circuit. Okay, so how to solve this second function? Second Foster second is always talk about the admittance function. So Simple, you have to first of all identify which function is given to you. Here impedance function is given, so but you are talking about the Foster second circuit, so take the reciprocal of that, so you will get admittance function, right? Impedance function is given to you, you have to find admittance function. Simple, take the reciprocal of this. So when taking the reciprocal of this, now see, this is nothing but here this function, okay, as s square plus 10. Now observe, this is nothing but here this format. Now you can also solve this circuit by using partial fraction, or you can also solve this circuit by using the uh, long division method or ordinary division method. So when observe that, when I use that circuit in long in ordinary division method, for example, we take another method here. I use long division method here. Okay, so for that you have to rewrite this equation in your factorized format. Okay, so first of all multiply this numerator, that is s4 plus 16 s square plus 4s square plus 64, right? And here s cube plus 10s. So this is nothing but here s power 4 plus 20 s square plus 64, and this is s cube plus 10s. Now simple, you have to multiply this sorry, divide this numerator with this denominator. So we already covered the Hurwitz polynomial criteria, right? So uh, proceed by that criteria, you will get some quotient here. So I not going to solve in detail. I'm just writing the questions what you will get here. You have to proceed with this. Okay. So for in first question you will get S. Second question you will get in first question you will get this S. But when you okay, okay guys, wait a minute. Okay guys, now see, there are, you can also solve this, but you will get some question here. Okay, actually solution is not with me. So यहाँ पे आपको कुछ क्वेश्चन मिलेंगे. So that question is represent for something. For first question is s, you will get because both are same. So simple, you have to multiply this s term, right? Second question भी आपको कुछ मिलेगा यहाँ पे. So that question, but and similarly identify how many question you will get. I don't know, but there are n questions suppose you will get here. Now at the end you have to analyze. Now see, this is the admittance function, right? So admittance function, so this is nothing but your ladder format. So first question is represent your y, second question is represent your z, third question is represent your y. Okay, so in such a format you will get the questions. Now at the end you have to represent your admittance format, right? So y जो भी आपको y के क्वेश्चन मिलेंगे, so that compare that question, or first of all take the reciprocal of that. When you take the reciprocal of this second question you will get, this is nothing but your y1. Okay, this is your z2 and this is your z3. So you have to take the reciprocal of this, so you will get y2, right? Once you will get the y2 value, the simple, uh, these are in parallel, right? Y impedance is nothing but your y1 plus total y is nothing but your y1 plus y2 plus y3, right? In such a format. Now you have to analyze for with for what, the same way which I cover here, right? For admittance format, you have to represent with this format, right? So similarly, you have to analyze this y1, y2, and y3 for such a network. Okay, for such a network. So you can directly connect that whole circuit in parallel format. So this is a one method, and second method is, suppose if I uh, use this first question, right? After this first question, I observe that my denominator degree is greater than my numerator degree. So such type of problem, we are proceeding with partial fraction method, right? So you can also proceed from this. After getting this first question, you can also proceed with partial fraction method. So this is a second method. So at the partial fraction method, the method are same, which is already covered in this first format, right? Here we also cover this partial fraction method. So for but what are the condition to apply the partial fraction? Your numerator should be less than by your denominator, right? So when you observe here in this question, your numerator is degree is higher than your denominator. That's why we are going to this long division method. But once you get this s term, or you can say once you get the denominator degree is higher than your numerator, then you can also proceed your problem with your partial fraction, and the process is same. When you get this term, but and then you have to analyze what circuit is given to you, that is Foster 1 or Foster 2. So you have to convert your element with your respective with that respective circuit, right? In Foster 2, we are dealing with admittance. In Foster 1, we are dealing with impedance format. So at the end, you have to just add up the whole circuit. For getting the equivalent circuit, you have to add up the these different types of admittance, right, which you are getting in that circuit, in that question. So and then compare your this equivalent circuit with this standard format, which is I provided here, right, in this circuit. Then connect your circuit accordingly. Okay, so these are the method. And one more thing, when you how to say that how many element are there in that circuitry? Simple, by observing the numerator and denominator term, which is means highest power of s is represent your number of elements. See, what are the highest power of s here is s to the power of 4 in denominator. It is a irrespective term. That means you just observe what are the highest power of s, right? That directly indicate your number of energy storing element in that circuit. So see here, what are the highest power of s is s square into s square is s power of 4. That is 4 energy saving element are there in your circuit. So see, how many element we are getting here? 4 element, 1 2 3 4, right? So I can say that here some more, one more y4 term is also is there. Now see, because your original circuit, what is the highest power of s is s power of 4. So there are total 4 element are in your circuit, energy storing element, or you can say there are 4 admittance you will get. Sorry, 4, not a 4 admittance, there are 2 admittance you will get by 4 element. Okay, there are combination of these two, such that this is a combination. This is nothing but your z1, right? And this is your z2, and each z1 is combination of 2 element. So total is 4 element. The similar way, this, I hope this is clear to you. Now you have to solve this problem and compare the solution with your CL Vada book. I will upload that PDF. Actually, that PDF is not ready. Okay, so this is for your Foster circuit. Now we proceed with causal circuit here. See, there are some steps involved in that. We will going to see here. Now, similar way, Foster circuit is talking about the series combination of impedance, and for Foster 1, and Foster 2 circuit is talking about the parallel combination of your admittance, or you can say admittance function, right? But here causal form it is a combination of series parallel circuit. Now the cover form is divided into two form. First is uh, core first form and core second form. In first form is nothing but what explain first form. L is in series and C is in shunt in ladder pattern. Okay, I already take one ladder pattern right in our starting classes. So at that pattern, core first form is explained only. Inductor means inductor is connected always in series, and capacitor is connected always in shunt in for this core first form. Okay, now see there are different combination of core first form. First is LC network. L is always connected in series and C is always connected in shunt, right? Of this network. So this is the different combination of ladder circuit. Now this is second one is RC network. Now C is always connected in shunt. So the another quantity is another element is R. So R is connected in series for this circuit because we can't connect this C in series for this circuit because this core first form is doesn't allow to connect that C in series with your circuit, right? So similarly this RL network. So L is connected in series with this. So this is a general and standard equation for your core 1 format, core 1 function, right? So you have to compare the equations or whatever the function is given to you. If you want to draw the core 1 circuit, so you have to proceed accordingly. Okay. Now, second, for core 2 form, so it is a just opposite to core 1 form, right? C is always in series and L is always in shunt. So we note that C is always in connected in series and L is always in connected in shunt. Similarly, just opposite to your core 1 for circuit. So this is a standard or general circuit for your core 2 circuit. So C is always connected in series and L is connected in shunt. So this is a LC network, this is your RC network, and this is your RL network. Okay. Now, one question on the basis of this. So this question is provided you. You have to find your core 1 and core 2 circuit for this function. Now, first of all, you need to keep in mind how to solve that, or you can say this is a step to solving this core 1 circuit and core 2 circuit. There are one special condition also is there when the degree of both numerator and denominator is same. We will talking about that. Okay, so first of all, see here, uh, in core first, what is the first step? This power is in descending order. You have to arrange your power in descending manner, and in for core 2 circuit the power is in ascending manner. Now see, for this is nothing but your power, right? This is in factor format, so you have to multiply with both of these, so you will get the quadratic equation of this. Now this is the equation of order 2 and this is for order 3, right? Now you have to arrange in descending order from this. So this is already arranged format, right, for core circuit. But for this core second circuit, you have to write 4 is first, then 5s, then last is s square. So accordingly you have to arrange first. Second is to get the function z of s or y of s such that the numerator is greater than denominator for core 1 first, right? For core 1 circuit. Now it and see, this is a irrespective of function is given to you. When you proceed the core 1 circuit, you have to arrange the function in such a format your numerator degree is greater than your denominator degree. So here is impedance is given to you. Now the degree of numerator is 2 and degree of denominator is 3. So this is not in this format, right? So you have to reciprocal of this CO function. So 1 by z is nothing but your y of s. So for core 1 circuit you have to proceed this y of s function for specially for this function, right? So there are different functions. You have to first of all identify which power is more, either numerator or denominator. So depending on that you have to proceed. Okay. So in core 1 circuit you need this numerator degree must be greater than denominator degree. So here you have to take the reciprocal of this function, then you will proceed. Okay. Then third one is divide it, simple. So and the on other hand core 2 circuit, you have to arrange your function in such a format your numerator degree is less than of your denominator, then divide it. Now observe here, this function is given to you. You have to proceed with both this core 1 and core 2. So first of all we proceed with core 1. So when I take the core 1 circuit, now follow these steps. This is already in descending manner, right? So the second one is you have to means your numerator degree should be equal to sorry greater than denominator. So you have to take the reciprocal of that. When you take the reciprocal of this network, this function, you will get admittance function, right? This is the impedance function is given to you. Now this is a standard format this for this core 1. Okay. So this is your standard format for this core 1. Now simple, you have to divide this network. So divide this by this ordinary division method, or you can say long division method. So this is nothing but your divisor, and this is dividend, and this is your quotient, right? So when I divide this, you have to simple how to get this s cube here by taking this is nothing but your s cube. So you have to multiply s factor with this whole equation. So you will get s cube. So this term will cancel out. Okay. So when I solve this, you will get this is your remainder for this, and this is your first question. This is second question. Then you have to solve, proceed accordingly. At the end, when you will get zero term here. Now observe here, you are starting with your admittance function. Okay, you are starting with admittance function. Admittance is your original function for this, right? Because we convert that function with admittance format, and you are starting the division from this admittance function, right? So that's why this function first function is your admittance y1. Now the second function, in previous classes we already see that how to write this function. Y is nothing but for this state y is nothing but your y1 plus remainder upon divider, right? Remainder upon divisor. So why we are write this is nothing but your admittance. But when you see but the actual, see observe here, you are dividing this term, this remainder with this divisor, right? But you are writing here remainder upon divisor, so that is wrong. Actually this is not wrong. So here is nothing but here, what is the term indicate here, that is your z2. So for admittance function you are just reciprocal of that, that's why you are writing here remainder upon division. So this is satisfy your condition for admittance. But when you directly observe from the question, this second question is indicate your impedance function, okay, for this whole admittance function. So you can generally, there are trick, you can say this is a trick. Once you get the admittance function, so second function is always impedance, then admission, then impedance, then admittance, and take write the number 1 2 3 4 accordingly. Okay. So once is you get, if you get here impedance function, then your second question is admittance, then your third question is impedance, then your fourth question is admittance. So accordingly you have to proceed. So this is your one trick, you can remember this. So in first question is your admittance, so second question is your impedance, and third one is admittance. Now I also explained in Laplace domain on, or in Z transform, S transform. S domain. Resistance is indicate, this is a value, right? And this is indication in your circuit. So this is nothing but your A is represent your resistance, and AS is nothing but your LS, right? So L value is A here, and this is A by S is nothing but your 1 by C. Okay, 1 by CS, how to represent this? 1 by CS, right? CS. So what are the value of C here? C is nothing but your 1 by A, right? Compare these two equations. So similarly, in in admittance function, the Laplace domain is represented with this, and the equivalent circuit is this, right? So you must be remember this, and by observing this, you can just compare. Now see, this is your y function, this is your y1. Compare the coefficient of y1, and here you are talking about y function, right? Y function, admittance function. So admittance, for admittance function, you generally observe this. Now this is your y1. Y1 value is 1, right? So here C value is A, right? This is, compare this with this. So here C value is A, and this is Z2. So how to find out your Y2 is 1 by this Z2. So Y2 is nothing but your 2. So 2 is represent is constant, and that constant is represent here 1 by A. Okay, 1 by A in ohm. So simple. I just represent that all element. Just compare this all function with this. So represent that function with this admittance function. Okay, for this year, this is for your core one function. Now similarly, this is some note. You can just remember this. Once the first question is y, then you have to start with this figure A, and when if first question is z, then you will proceed with figure B. Okay. Now the same way, second function is you can also solve that function with the same process. Simple. You have to follow these steps. Okay, which I explained already. This steps you have to follow. You have to arrange your numerator degree is less than for denominator for this cos core 2 circuit, right? And then divide it, and the same way, at the end you have to compare with this function and draw the circuit. Okay, draw the circuit with this. Now here you are comparing the impedance function, so impedance function is represent with this format. Okay, so these are the process. You just observe it, and when you find, this is your equivalent circuit. Now, now one more thing. When the numerator degree and the denominator degree or are equal, then how to proceed your circuit? Yes, when the numerator degree and denominator degree are equal, then how to solve that circuit? Simple. In this circuit, you have to compare the critical pole condition, right? For example, in, in core 1 circuit, we are dealing with numerator degree is greater. For example, in core 1 circuit, there are some function is given to you, right? Function of S is nothing but your q p of S divided by q of S. This is function is given to you. Same way here, function is given to you. So if the if I talking about this core one circuit, then in that circuit you have to use the pole zero concept. If the numerator degree is equal to denominator degree, then 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 you have to take the uh, see, in this format you have to take the pole, critical pole, right? You have to first of all observe what are the poles and zero. Suppose there are z1 and z2 is are zero for this function. Okay, and p1 and p2 are pole of this function. So this is a pole zero plot. So accordingly, if the poles, what are the critical pole which is nearer to the origin? So observe the critical pole. Suppose this is your pole p1. Okay, P1 for this function is your critical pole, and rest of the term for this side. This is your P2 and this is your Z1. This is your Z2. Okay, this is your Z2. So accordingly, you have to proceed. If the critical pole here P1, so P1 is nearer to your origin. So P1 is your critical pole. So at that time, you have to take a pole from your Z of S, right? अगर P1 critical pole है, अगर pole critical है, then you have to use Z of S. If the zeros are critical pole, if the zeros are critical value, right, then you have to take your y of s मीन्स जब पोल्स नियर टू द ओरिजिन होंगे तब आपको z of s लेके सॉल्व करना है राइट सर्किट when the zeros are nearer to this origin then you have to take y of s for this core 1 circuit. And the same way, when the zeros are critical value means nearer to origin, so you have to take z of s for this function. And when the poles are the nearer to the origin, or you can say when the poles are critical pole, then you have to take y of that function. Okay, simple. ये understand आया हुआ क्या आपको? Are you understood this point? So when this for this you have to analyze your pole zero location, okay, for the given function. So once you observe that, then you have to analyze which pole or zero is nearer to origin, or you can say which poles are critical poles or zero. So accordingly, if the poles are critical poles, then you have to use this. If the zero are critical value, then you have to use this admittance function for this core one, and the same way for this core two. Now, uh, what does it mean? You have to proceed with this. Okay, guys, that's it for this poster and core circuit. Now I will provide this some example in your assignment. Then you try to solve it. Okay, guys. Thank you for joining. You can do now. Thank you.